What if you could just put your entire life on autopilot and things just happen and you don't need to even think twice about it? I partnered up with the amazing team at Kestra to show you how orchestration is changing the game for me and anybody that is building automations. So, orchestration is a really kind of fancy tech word that basically just means if this happens, then do that. Or if this case is true, then cause this output. And what's really interesting is this year, I am super passionate about working smart and working hard. Of course, I love working hard, but I love working smart and hard. And one of the things that I have been trying to do is automate a lot of the different processes that power how I run my business, how I live my life, how I optimize my health and my nutrition, and how I go about my day, and a lot of the work that I do. And technology is one of the best ways to power your world. And when you can just put systems, processes on autopilot, you then just are empowered to not just feel like you're being held back by you needing to do something. You could just have technology go and do it. And one of the goals for me this year is to get smarter about investments in the stock market. I am so passionate about finance and investing and leveling up your life. And one of the things that I wanted to do was figure out how I could become a better investor. And one of the things that I found out was, I can automate a script that can go and basically get some data here, or I could automate this process and get some data here. But I didn't have I didn't have a system in place to be able to just orchestrate a whole portfolio analysis. And that's where I feel like Kestra aligns so well with this goal that I set for myself, where I wanted to automate a complicated process, and specifically getting data about stocks. It is so expensive to get stock market data. If you've ever tried to get the premium data feeds, it can be tens to hundreds to even thousands of dollars a month just to get access to premium data. But what if we could just do all that for free in a dashboard, and it lets us know what's happening throughout the day as the stock market is open throughout Monday to Friday? That is exactly what we're going to do on this video today. I'm super excited, again, to be partnering up with Kestra to show you this, because their whole system is open source. You can use it for free, and that allows you to leverage free APIs, which we're going to learn about, so that you can then power a stock market analysis that's completely automated around the clock. You don't even need to think twice about it. So I'm super excited about this build. I think that this is going to be really helpful for a lot of people that want to learn how could you use Python and YAML to write scripts that can then automate really complicated business processes. I'm so excited to be bringing this video to you all. So with that, we will get into how we're going to set this up. So get your laptops, get maybe some water, get some tea, get some coffee, and let's get ready to code some YAML with Kestra. So as you'll see on the homepage, if you go to kestra.io, you'll see their website. And specifically, one of the things that I really like about it is the whole idea of automating and scheduling. And you can really just start making your sites look like this. So you could visualize dependencies. Here, you sort of write your code as a YAML file with an ID. In the namespace, you have some tasks. You then give it an ID and then a type, and then you start telling the tasks basically what they are. So you might have git clone, where you're going to take the code of a browser. So every time that something is committed to the main branch, we're going to do something. Then you do a flow for each item, and then you will run something in Docker. You could then, for each, send a message, fetch some data, process data, and then load that into the cloud, for example, in S3 in AWS. You then can see all of these different executions, which is really cool and very helpful for debugging, but also in terms of these executions, you can also see how long they're taking and optimize. So this is used by so many different companies. They have all of these different features, but specifically having a declarative workflow enables you to make sure that as you're debugging, and you're working through basically your code, you can run this anywhere, but know that you are defining logic that then can be scaled, can be copied and replicated across your team, across different environments, really, really simply. Also, very, very, very fast development cycles means that you'll be able to scale as you build, and it also has an API first design so that we're able to just pull from all of this open source code, completely for free, and leverage all of that in our multi-tenant architectures in a super scalable way. Also, the dashboards, we're going to go into all of this stuff, but again, workflows at scale. We are talking about making workflows that automate and integrate into your regular processes, and thinking about cron jobs. So these can be happening all around the clock. And then you don't even need to think twice. So they have about 500 of these different plugins. We're going to see how some of these work. And I'm just super excited to show you all this build. So to give a high-level overview of what we're going to be building together, we're going to be building our own Kestra dashboard that is optimized for analyzing a series of stocks and pull their price every 5 minutes. Now, if we were going to do this with premium stock data, that would be API calls, which then we would need to calculate and count. But we're going to be able to do this completely for free throughout any of the times in which the stock market is open. So you'll see here, when we are on the dashboard, this is our main home base. And one of the things that I love about Kestra is the ability to have this very visible, very declarative, very modular sections to help us see really what's going on here. So when we're developing, we really need to know where things are failing and where things are succeeding. So as I was building out this software, I was able to track and see how many of my builds were successful, how many of them failed in terms of the executions. When you can see the failure rate, you also might want to track that to say, basically, when I'm building these containers and they're running, how am I doing? And also see the number of flows. How many of these cron operations are firing off and giving us, data, right? You can also see this over time per day. So all this data gets stored in our Kestra database, all for us. As we scroll down, we can also see any executions in progress. We can also see when the next scheduled execution is there. So this is my simple stock market monitoring system. And we see that that is on our own custom schedule. You could also have it daily or weekly, but we're set to do Monday to Friday. And then we can also see how many executions per namespace are happening here. And of course, with the logs, if we go to flows, I do think that flows is really helpful here, because then we can actually see the number of executions, and we can actually see, if we zoom in here, we can see that them, succeeded or failed over a given time. And that becomes really helpful. We can also see how many flows we have that are successful, how many of them failed, and also the warnings that are around them. And I think in terms of observability, this is really important because it helps you see really what's going on. Because if you build software and you just don't get data, it doesn't really help you to just know that, okay, it's just empty. It actually will tell you if it built, if it failed, and these are just the flows. So this is if the code failed to build. Then in terms of executions, we could even see when they were successful, when they failed. These were all from successful. So there were a lot that were running from today. I'm going to try to find where it was. Okay, cool. So this was from very early in the morning today, and it failed. So if we wanted to go and investigate this, we could click on this, and it's going to say unable to find current data used in the expression in this. So this is going to tell me to go back to my code, and it will help me see that there was an error sending this alert. Now, we can also see in terms of the schedule, right? We can see basically what's happening. We can see that this is doing it every 5 minutes. That's why it increments up to 5, and this was the previous one. So we see that this was running on a schedule. I do wonder if maybe this was something that was an issue with getting data from the stock market, or it could have been something that was basically from within my system. So it seemed like this might have been a code issue. So then we could just go back into the code and then figure this out. Obviously, it was an issue with the code. I was able to update this. And then that's why you see back under the executions, that's why all these other events all succeeded after that one fail point. I think that was like the fourth one. Yeah, fourth one. So after that, like everything succeeded. So that's where this becomes really helpful, because you can get these alerts and really see what's happening behind the scenes. So really powerful. And also, as you'll notice too, that when we are running this, we're running this, every 5 minutes here. So you'll sort of see that as we're, basically building our event-driven architecture, we want to make sure that this is running in an optimized way. So that's where we're able to do this every 5 minutes. One thing to note though is that because I'm running this in a virtual machine, we do need the virtual machine to be running. So we're going to talk about that at a later point when we actually start building this. You could develop this locally, but I'm developing this in the cloud because it's super easy. So that's why I'm doing it like this, but you also might do it a little bit differently. But to each their own, choose the best tool that's for you. But again, love the ability to just go in and granularly see all this data. So when we go and see that something was successful, for example, let's go back to our executions and let's see the most latest data. So we see here that this is the latest data. We go to outputs. We see that our market monitor is here. We go to our variables. We see our current data here. And now we see here that there is 0, 1, 2, 3, 4. So this is the price of Apple. So we can see that this is 237, Google is 200, Microsoft is 414, Amazon is 234, and Nvidia is 124. So I do want to see if we can catch it. Okay, great. So this just happened. This was just created a few seconds ago, and this is now running our log. So if we wanted to run this, we could see that this was successful. This was literally just created and it was successful. We can see the latest data. If we go here to outputs, market monitor, to our VARs, our current data, boom. So now we have this. So let's actually see if this is true. So if we go to Yahoo Finance and we say Apple, we go here. So this was 237 and this is 237. 237.5. Yeah. This was 5.9. Yeah. So this was taken just now. Let's also see about Google. So we could copy this. We'll go to Google, see the price. So that's 287, 288. Yep. Very similar. Microsoft, do the same thing. 414.99, 414. Yep. Yeah, so it's going to be a little bit delayed, but that's also in terms of the sense of like with the API, the market's moving all the time, but very, 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 very similar to the data that we would expect. Also, Amazon 234. Let's check that. 234, 64. Yep, exactly. Yeah, same. And then check Nvidia. Cool. So go to Nvidia. That's 124.65. And that's 124.9. So that's kind of where like you will sort of, if there's a lot of trading happening, that's where like you could sort of see that this was happening over this period of time. And then this is a lot of movement over the course of a day. So that's why it'll be helpful for us to go back into our log. And then, for example, we could go back to our executions, go back here, go back to where it was price before, and then see our outputs and then see how much this changed. So again, and we're able to get all of this for free. We're using the Yahoo Finance API, which is the Y Finance package in Python. But again, really great way to see this. Also with the logs, we can see very clearly with the logs of errors, warnings, info, and debugging, and really to help us track how our scripts are running. And then also with the namespaces, you can track, namespace. So I was making this namespace here. You can actually track all of your executions by namespace, which I find really helpful if you're trying to segment different workflows in different ways. The other thing that I think is really cool is blueprints. So if you want to talk about blueprints, this is a really great way to just be like, I want to create an S3 bucket. So these are recipes where you could just go in and add in your AWS API keys. And then now through IAM, now you just add your keys in there and now you'd be able to create a bucket. Let's say that we wanted to then go back to blueprints and we wanted to do something with event-driven architectures. So this is where, like, if we wanted to do data ingestion to S3 with a data lake managed by Apache Iceberg, we have this whole YAML file. We just need to pass in our keys and different things. And then we can pass information through these tasks. So we have our outputs, and then we'll have our inputs. So output location is here. So that's where you could just build this whole event-driven architecture very easily thanks to Kestra. Other thing that we're going to talk about later, but plugins, there's like 500 plus of these plugins to be able to pass in. So you could do AWS, you could do specific AWS services, you could do AstraDB, you could do, again, AWS, ClickHouse, all these different ones. You could also do API calls. You could do any of these other things, which is great. You could do SQL, Databricks, Postgres, all of these different Git, all these different providers. You could do Google Cloud, Google Drive, Google Sheets. Yeah, so many of these different ones. Slack, Twilio, Power BI, all of these different implementations. Snowflake, Oracle, Redis, so many of these different integrations. Also Terraform, you could throw that in there, Weaviate, Zendesk. So this is our dashboard. So we're going to be building one of these, together. And this is where it's going to show you how you could leverage YAML and Python to start automating, your stock market analysis for your portfolio. Now to get started, I am setting up a Docker dev box inside of Code Sandbox. So you can, if you install Docker Desktop, you can run Kestra on your local machine. I'm just going to show this in Code Sandbox because I think this makes it a lot easier to see, and also it gets rid of the barriers of needing to install Docker and all of the different virtual machine configurations. But if you can install Docker, you can install Kestra there. So what we're going to do is that we are going to go to create, we're going to click Docker, and then we're going to call this Kestra stock automation pipeline. And you could choose basically any of these types of servers. I'm just going to choose the micro one, and we will click create dev box. So it is setting up now, and now we have our Docker container. So if we want to just make sure that this is working, we of course can zoom this in and we can say Docker PS, and this is going to tell us just zoom out now so you can see that on one line. So we can see here that this is our dev container. So Code Sandbox is running Docker for us. So this is this Code Sandbox dev box container. So we can see that this is running with Docker, which is great. Now what we're going to do is that we are going to now install Kestra and run this with Docker. So how we're going to do this is that we're going to go to the docs. We'll then see get started. We'll go to installation guide. We're going to say Docker. And now we're going to run this command. So we're going to copy this and we're going to put this in our terminal. Just like this. So let's talk about all these different parts and what actually this means. So when we are setting up our Docker to run Kestra, what's really happening here is that we are going to tell Docker to start a new container with Docker run. And I'm going to boost this up just a little bit so it's a little bit easier to see. Okay, cool. So we're going to use Docker run, and that's going to tell Docker to start a new container for Kestra. We're going to do pull always, and that's going to always get the latest version of Kestra. This is important so that we're always up to date. It's incredibly valuable that it's open source, and we want to make sure that we're getting the latest and greatest. Then we're going to do RM, and that's going to clean up basically everything automatically after we're done. And we're going to use IT, and that's going to make it interactive so that we can see what's going on. We're going to put this on a port. So that's where it's going to open up this port 8080. And that's going to allow Kestra to be in our web browser so that we can make it an interactive browser. And that we're going to see that in the preview window there. And then after that, we're going to use this use root, and that's going to ensure that everything runs with admin privileges, which is needed to get all of this running. We're then going to use the v flag, and that's going to connect our computer's Docker system with Kestra's container, which we're going to get from here. And then Kestra latest just make sure that we're getting the newest version of Kestra. And then we're going to then start Kestra in local mode in our virtual machine. All right, so we're going to run this. It's going to now start pulling from Kestra. And we're going to see some text scrolling up on our terminal. So this is going to be Kestra starting up and downloading. So once the download is complete, then this is going to boot up Kestra, and we're going to start being able to have that all begin loading onto our virtual machine. So it's extracting all of the code. You can see here that this is 1.6 gigabytes. All right, so we can immediately see that this port 8080 has opened. We're going to click Open Preview. We're going to now make this a little bit smaller. And now what we can do is we can close this. And now what we can do is we can see that now we have Kestra loaded onto our machine. So we can close this for now. And we can also move this there. And now we have a full screen of Kestra. So again, this is what you're going to see when it welcomes you. Obviously, we haven't created any flows yet, but this is the welcome screen here. So again, if you were to go to dashboard, it's going to redirect you to this welcome screen because we don't have any flows, we don't have any executions, no logs, no namespaces, but we do have blueprints if we wanted to use those, plugins if we want those. We have all those features, but we don't have any flows. So we're going to create our first flow together right now. So now what we're going to do is that we are going to open this up in a new tab. So if we press this button on the right, this will open up a full screen version of Kestra, our dashboard. So just be a little bit bigger and easier to use here. So now what we're going to do is we are going to now be able to start working and plugging away on our first flow. Now, one of the best features of Kestra is, in my opinion, their observability workflow when you are building these automations and these orchestrative patterns. So what we're going to do is that we're going to build a flow, but we're going to build it and it is going to break. And we're going to recursively go through solving this issue. And we're also going to learn a little bit more about how Kestra works in this process. So hopefully this will be eye-opening to you and then also help you understand a little bit more about how Kestra can provide value for you, as it was very helpful for me when I was writing this code for this video. So we're going to click on Create My First Flow. We're then going to be met with this. I'm going to just make this a little bit bigger here. Make that a little bit smaller. So what's really great about this is that it gives dynamic documentation, so you can really learn about the different parts of how this is set up. So like ID, namespace, but then if you switch to tasks, it then will start telling you like these different parts about what to think about when you are working with properties and all of that. So what we're going to do is that we are going to start coding, and we're going to call this Y Finance Flow, because we're going to use the Y Finance API, which is going to pull from Yahoo Finance's financial data. We're then going to click your namespace, and that's going to be in the namespace. So that's basically what we could do. So I'm just going to call this Tech Stack Playbook. So that'll be the namespace here. Now under tasks, we're going to create a task, and we're going to give an ID of stock data. What we're going to do is that we're going to then define the type. So we define that with io.kestra.plugin and then dot something else. So what we're going to do is that we're going to call scripts. We're going to say Python, and then we're going to say script. We're going to make this a little bit bigger. Now what we're going to do is that we are going to add a before commands. And what we're going to do here is that we're going to say pip install yfinance and Kestra. Cool. Now what we're going to do is that we're going to define our script. So we'll say script. We'll then do the vertical line, and then we'll say from Kestra, import Kestra. We'll then do import yfinance as yf. Do an enter, and then we'll do our try except handler. So this will be for getting our stock data. So we'll say Apple equals yf dot ticker, and this is the way in which you use yfinance to get our financial data. So we're gonna basically, we already define yfinance, but then we say dot ticker, and then you can throw in a ticker symbol to be able to then get that value. So we are going to be looking at Apple, and that's how we do that. And then we want to get a history. So we'll say hist equals AAPL, which is our variable up here. And then we'll say history, and then we'll say period equals 1MO for 1 month. So we want to get 1 month's worth of data. Now what we're going to do is we're going to say convert to records and send to outputs. So this is going to be how we are going to basically take our records and send this to our output, because we're going to ingest this data, but we do want to declare it and print it into our logs. So what we're going to do is that we're going to say data, and we're going to create a dictionary for our data to store it in. So we're going to say data dictionary equals hist. We'll say to dict. So we're going to use the to dictionary method for our history, and we're going to say call that records. And we can also make this a little bit smaller, just optimize our variables here. What we'll do now is we'll say Kestra dot outputs. We'll then put in stock data in our curly braces, and then we'll say data dictionary as our variable. Now what we'll do is we will say print, and we'll say successfully fetched Apple stock data. Then what we'll do is we will write our except. So we'll say exception as E, we'll say print, and then we'll print an error message about the error that we might get. We'll close out our F string. We'll raise E, and so far so good. Give this a save. We'll now see that Y finance flow is successfully saved. We'll close that out. And then now what we're going to do is we are going to execute this. And we are expecting this is going to error, but we're going to see why seeing these errors is important. So we will execute. And we're just going to click execute. We don't need to do a curl or advanced config. So we'll run this. It's going to go across the screen, and then it's going to give us an error. And it's going to say that it failed. So we see that it's using the task runner, which is this Docker here, provided 0 inputs. But then we see this and it says connection refused. So it's giving this Java IO exception, and then it's saying that the connection refused. Other than that, it doesn't really give that much detail, other than just that it's pulling information from Docker Java from GitHub. But this connection error is really important. And to fix this, we have to actually think about what's happening when we run Kestra. So we're going to do a whiteboard here. So when we are building our virtual environment, right? So we're going to just whiteboard this out a bit. So we have this code sandbox, and we're just going to label this as code sandbox. And this is a Docker dev box. So we're going to say Docker. So this is running Docker, right? So now we're running Docker. When we're running Kestra, we are going to be running a Docker container for this. So this is going to be Kestra, but this also is Docker as well. So what we have here is a case of Docker in Docker. And if you have a situation like this, you're going to need to use a specific processor for Kestra so that we can run this. If you're running this on a local machine, basically where you're not like instantiating Docker and then you like are running Docker within Docker, you won't need to worry about this. But because we are doing this inside of a virtual machine that is rendering Docker, we need to do this. And something that we can actually see here is if we were to open up a terminal, and I'm going to like make this a little bit bigger so we can see. So we'll open up our terminal. If we were to say Docker PS, we can see that there are two different Docker containers. I'm going to now make this a little bit smaller. It's a bit easier to see. Okay. So if we were to like, I don't know if we're able to like zoom in here. It's a little bit hard to navigate, but try to do my best. So there's this Kestra, and then the VS Code sandbox, right? So those are the two containers that are running, but we are running Docker within Docker here. So what we need to do is we need to add a specific processor that's going to enable us to navigate around this issue. So what we're going to do is that we're going to go right before commands. We're going to say task runner, and then we're going to say type. We're going to say IO, Kestra, plugin, core, runner, and we can press enter to autocomplete, and that's going to add that in there. And then we will give this a save. So now that we've saved this, we can now execute this code. And let's see what happens. So we'll execute the code. We'll execute. This will span across, giving us some progress. It'll keep running as it is building. And now we see this yellowish orangish bar. So this means that it was built, but it gave us a warning. So what we're going to do is that we're going to see that provided one input. We started with pip install yfinance and Kestra. It's collecting yfinance, so it's downloading this, and now it's running, collecting all of these different things like NumPy and all this stuff. So successfully fetched Apple stock data. So it was able to do this, but we can make this a little bit more efficient here, specifically because we see this error and it says, I can like try to zoom this in a little bit. So it's saying running pip as the root user can result in broken permissions and conflicting behavior. So what we want to do is that we want to, because we can download all of this stuff, but we do want to make our code a little bit more optimized. So what we can do is that we can go back to our flow here. And what we're going to do is that we're going to do a couple of things. So in some before commands, what we can do is that we can add in which Python, just to make sure that we are getting the right version of Python. We can also do Python version in case we want to debug our code and make sure that we are using the right version of Python. Also, something that we can do is we can say Python m pip install. We'll do -- user yfinance finance and Kestra. So we can get rid of this line. So now we're going to be installing this under the user. And then what we will do is that we will just review our script. So we're importing Kestra from Kestra and making Y finance as YF. And everything else in the code is going to be the same. Something that we might want to do is, in terms of outputs, we could just keep this the same here, but this is basically just getting us the records of that stock data. And we could also print, this value if we wanted to, but we don't necessarily need to do that right now, but we could if we wanted to. So we'll give this a save. And let's just update this here. So if we were to make this into an F string, we can add in our data. So let's try that, for example. So we'll add in the dictionary and we can give that a save. And we will execute this and let's see what happens. So execute it. So we got another error or warning. And now we're seeing successfully fetch the Apple stock data, which is here. So that's great. So we're able to get this, but it's still saying that it's running pip as the root user. So what we're going to want to do is we're going to refine this once more. So what we're going to do is that we are now going to, in this before commands, we're going to get rid of all this. So we validated that it works. But what we want to do now is we're going to say Python we're going to create a virtual environment. So this is going to package all of our dependencies and packages into a single place that we can then reference in Python, as opposed to installing everything in the root, which it doesn't want us to do. So what we're going to do is that we're going to say temp, say venv, where we want it to be created. So this is creating. We're then going to do a period. We'll say /tmp venv bin activate. And this is going to activate the virtual environment. And then pip install y finance and Kestra. And this is going to install. Cool. So we also have our process runner here. And we also have our Python script that we're using for our plugin. And everything else looks pretty good. And we still have basically all the code as the same. So we're going to give this a save. We'll execute this. And we're going to see what happens. So it's going to take a few seconds for this to all load. And awesome, we got a success message. So now everything is working correctly. We are using that virtual environment. We are then, collecting all of the packages, installing those into that virtual environment. We see that this is successfully fetching the Apple stock data, which is perfect. And we can also see all of this data that we're getting. So this is all data that we can get right from the stock market and all for free, which is amazing. So this is pretty great. So now what we're going to do is that we're going to now create another script that's going to get this. But what I really like about the logs here is that if we go back to logs, we can see all of our recent logs and everything that we were just doing. But if we go back to executions, what we now have is a trail of command of how this was being processed. So before we had a failed execution, then we had a warning, we had another warning, and then we had a success. So if you wanted to basically track what was happening from the failed state, you'd be able to go in and see basically like what happened. Can zoom out a little bit here. So that's where you can see why certain things happened. You can also go directly into that log and see what happened. You can also see the outputs, right? There was no output because it errored out. But if you go back to executions, we could go back to this warning, We could even see what happened here. And that's where we found out that pip the user that, right? That was that specific log. We go back here, and now we can go back to success, and we can actually see why this was successful. So that's one of the great things that I think about Kestra that's really valuable, is the ability to have this level of depth and analysis for what's happening over your profile. Because now, for example, I can see basically the success ratio of these successful executions. I can also see the failure rate. I can see how many flows I'm running. You can see, executions in progress. You can see like all these different values that are helpful for tracing and tracking. And you can also see this total execution pie chart as well. So I think this is really helpful because you can start to build a profile of what's executing and what are you creating and is it working or not working. So that level of visibility is really important for orchestration. And I really like how visible that becomes as we're building our containers in Docker. So now that we can see how we can get data from Yahoo Finance, let's kick things up a notch, and we're going to do some things with variables. We're going to use Kestra triggers to be able to basically fire off automations, and we're also going to learn how to pass data from one task to another task. So we're going to take our previous flow that we just made, which is this one, Y Finance flow. We're going to edit this flow. We're going to copy this. We're then going to go back to flows. We're going to create one. And we're going to now start a new one. So we're going to call this one simple market monitor. This is also going to be in the same namespace. And then we're going to create some variables. So the variables is an object, and we're going to say that this is a list of stocks. So we're going to say Apple, Google, MSFT for Microsoft, AMZ for Amazon, and NVDA for NVIDIA. And this is going to be our tech stock basket. So tech stock basket. Cool. So now we're going to proceed along with adding tasks here. I'm also going to increase the zoom here so that we'll be able to see this just a little bit better. Okay, cool. So now that we have our ID, which is our simple market monitor, we have our tech stock basket. Now we're going to start adding our tasks. So this ID is going to be called market monitor, and we're going to be using the same Python script plugin to run Python. We're going to also be using our task runner, same as before. We're also going to have the before commands, which is creating that virtual environment here. Now we're going to be installing also pandas as well as Kestra. And these are for our packages for installing. And now we're going to add something right before script, and we're going to call that output files. And this is going to allow us to generate a JSON file for the data that we will be creating in this automation. So this is great because the data will now not need to just be locked in Kestra. We could also port this out and put this into an application, send this in an email. We could save this in a data lake. We could port this data anywhere. So it's a great way to keep data in the platform and then also be able to port it out of the platform as well. So we're going to call this current market.json, and then we'll also add another one, and we'll call this one market history.json. Perfect. So now in the scripts, we are going to have our imports. So we have import Y Finance as YF. We also have our import Kestra as Kestra, or from Kestra import Kestra. We also will do import JSON. We'll also do from date time import date time, and we'll also do import pandas as PD. And then we're going to basically take this code and remove it because we aren't going to be using that anymore. And then we're going to basically define a function for fetching our stocks. So we'll do def fetch stock data. We'll then do symbols. And we're going to say vars stocks. And then we're going to take this and split it. And we're going to look for a comma. So what we're doing is that we're taking our variables from here, which we define as vars, finding stock, and then we're going to take each of these items and then separate them by a comma. So that's what we'll do here. Then we'll make data equal to an empty list. And we're going to say for symbol in symbols. We're going to try, use the ticker symbol and equals yf. And we'll do yf.ticker symbol, kind of like what we did in the previous flow. We'll say history equals ticker.history. And we'll do 1 day. Interval will be 5 minutes. This will correspond to us tracking this every 5 minutes. And we'll say if not history empty. We'll say current data equals, and we'll make an object of this. And this is going to have a whole bunch of information. So I'm going to copy this object here, and then we'll walk through what each of these is doing. So in our current data, we're going to have a symbol, which will be the ticker symbol. It'll have a timestamp, which we're going to use date time.now in ISO format. We're going to have a price, and this is going to be a floating point. So this could have a lot of decimals because it can be very exact. And then we're going to look for the volume. We're going to look for the change over time, the daily high and the daily low. And that's going to all be packaged into this current data object here. Then what we're going to do is we are going to then take data and we're going to append current data to that data object. So remember, we were creating this empty list. We're going to then add this current data into this and basically fill this for each symbol in our list of symbols, which gets defined by all of our stocks that we listed up there. Cool. So then what we're going to do is that we are going to then check where if. So we want this to succeed with the try catch, with the try, but then we're going to do except, and we'll say exception as E, and then we'll say print F, error fetching symbol, and we'll do str E, close out our F string after this. So we'll basically say error fetching symbol with the string of the value, and then we close it out. And that's great. Then what we'll do is that we will look for that level of where the for symbol was, and then we're going to then save snapshot. So what we're going to do is we're going to say with open, we'll say current, because this is we were going to be working with the file of JSON, so we're going to say current market JSON. We're going to write to it as F. And we'll say JSON dump data F. Cool. So then what we're going to do is that we are going to then append to our historical data. So then we'll do another try, and we'll say with open market history.json. So this is, again, like the file number 1, which we had here. Market history is going to go down here. So we have our market history, and then R as F, and we say history equals JSON load F. Otherwise, we're going to say except file not found error. we'll say history equals empty list. And then we'll say history extend data. We'll say if length history is greater than 288, we'll say history equals history minus 288. And then we'll work with this JSON again, and we'll say with open market history.json. We'll write to it as f JSON dump history f. Cool. Then we will return the data, and then we will basically add some more stuff, basically at the same level of the definition of the function. So here, we want to go back to here. And this is where we're going to now say num stocks current data, and we're going to set that equal to fetch stock data function. So num stocks, we're going to then be using that with current data. So current data is right there. So we're going to say if num stocks equals 0, we'll raise exception. We'll say failed to fetch any stock data. Then what we'll do is we will pass data to the next step. So we're going to use Kestra outputs. So Kestra output, we'll say Kestra outputs. We'll then say current data is set to current data. And then we're going to be working on our next task. So where this one was the market monitor, we're then going to now make our next task, and this is going to be for generating our alerts. So we'll say ID generate alerts. We're basically going to copy the same thing that we have up here, which is all of this. Mostly all of this. So we have our type, which is the Python script plugin. We have our task runner. We have our before commands. We have all that stuff. But we're going to add a specific function right after our task runner. But before commands, we're going to say run if, and we're going to have a statement that's going to check if execution.tasks market monitor status is successful or not. So we want to make sure that this succeeded before we run this. So we'll say that that's success. And as long as this previous step, because we have market monitor, and that's this task. So as long as this task ran and was successful, then we can run the generate alerts. So that's good. Now what we'll do is we'll say before commands, and we'll do our creating of the virtual environment, which is this specific step. And then we're going to do that temp VNV bin activate right here to activate it. And we don't need to install those, but what we will have is an alerts JSON. So we'll cut that out, and we'll just call that alerts JSON. Now what we're going to do is that we're going to update our script. So we're going to keep JSON, we're going to keep date time, and we're going to include Kestra, but we don't need Y finance anymore, and we don't need pandas. We just need those three. So then what we're going to do is that we are going to write a little bit more Python code. So we are going to then continue along. And from here, we're going to receive our data from the previous task. So we'll say get data from last task. And we're going to say current data equals. And then we're going to use Kestra outputs. So we'll say outputs dot market monitor dot vars dot current data. And that current data comes from up here. So that's where we get this current data. So we're basically saying, hey, let's take this and we'll import it. Then we're going to write a function to check our alerts. So we're going to say def to define our function, and we'll say check alerts. Then what we'll do is we are going to parse our JSON into a string for, or basically this is going to come in as JSON string, and we need to parse that into a Python object that we can use in our task. So we're going to set alerts to be an empty list. We'll then say for stock in current data, and we'll say if, say AWS stock change, and we'll say if that's greater than 1.5, we'll do alerts append, and we're going to create an object of this alerts appends. So we're going to go enter, and we're going to pass this in there. So this is going to be a level, this is going to be warning, this is going to be the symbol, and that will be the stock symbol. There'll be a message of price movement of stock change, and we're going to turn that into a %. And then we're going to do the timestamp of that alert, of that change. Then what we're going to do is that we are going to then go down here and we're going to save our alerts. So we're going to do a try statement. We'll say with open. Now we're going to do alerts.json, which is similar to what we're going to be outputting here. And that's where we're going to be putting our file data in. We're going to say read it as f existing alerts equals JSON load f, and then we will say accept file not found error. Say existing alerts equals this. We'll then say existing alerts extend alerts. Then we'll say if the length of existing alerts is greater than 50, say existing alerts, I'm just going to copy this. We'll do -50 colon, and we'll say with open alerts.json with as f, say JSON dump existing alerts f, and we'll say return length of alerts. We'll then go back to the level of the function, so that's here. And we'll say num alerts equals check alerts. We'll print this up and we'll say f string generated num alerts new alerts. Close out the f string, and then what we will do is that we will then say, so now to basically create a schedule of this, what we're going to want to do is, actually I think we need to smooth this out just a bit. Yeah, I think actually that should be fine. So then what we want to do is that we want to make a have this run on a cron job. So every time that we want to run this is every 5 minutes. And this is where we're going to be basically creating our automated stock tracker so that we can always be getting the latest data all around the clock. So we're going to say triggers, and then we're going to say ID, and then we're going to say schedule. We'll then say type, and that's going to be io.kestra.plugin.core.trigger.schedule. Then what we'll do is we'll say cron, and we're going to do a *5, and we're going to do 1, 2, 3, 4 for that, and then this is going to be every 5 minutes. Okay, cool. So we're going to give this a save. That was quite a lot of code. So now what we want to do is that we want to execute this and see if it works. So let us find out if this will work. So we did get an error, and it's unable to find stocks using the expression from Kestra import Kestra. So we're going to go back to edit flow. We'll go back to our variables, and we define this as stock. This probably should be plural. We'll give this a save. Let's then go back to execute. This will continue to run. And the first task completed, and the second task completed. So that's great. So now what we did was we're able to get an input here, and we're generating alerts. And we can also see that our market monitor ran. So we did all the installations and everything, captured 2 outputs. So let's see in the outputs. So when we go to the output, this is where we're going to be able to see all of our data. So we see our market monitor task. We see that there is some current data, and we see that now there's values, and we can zoom out just a bit. Just a bit here. Okay, cool. And then we can zoom in here. So we've got Apple, we've got Google, we've got Microsoft, we've got Amazon, and we've got NVIDIA. So these are all of those values, and this is in our market monitor task. And we also have exit code and output files. So this is where if we wanted to download this JSON, we could also download the market history as well as the current history here, which is great. So we can also preview this data, and we can see that this is all the data that we would need that we exported, and also the current market. We can also preview that as well. And this is the current market that we have. Then when we generate alerts, again, we have our outputs, and we have our this, and there's no preview because we do not have any alerts right now. But if we did, they would be in there. So now what we're going to go is that we're going to go back to our dashboard. And what we're going to now do is we are going to now see under scheduled executions, we now see that there is a schedule set for my TechSec Playbook namespace for the simple market monitor flow. And our next execution is for right now, actually. So we now can start to see our executions, and this failure rate should hopefully start to increase as we continue to have more successful executions. So if we go to executions here, we then had our fail. This was from earlier. And now we have these 2 successful runs. So now every 5 minutes, we're going to then be running our simple market monitor to be able to then check this. So I'm going to pause this video. We're going to come back after it's executed a bunch of times, and then we'll start to see how this will change here. So we have, these messages here. We also see all these logs. And of course, in the dashboard, we see our success ratio and our failure ratio. So these will start to change as we continue to run our workflow to automate our stock market analysis, all for free. So we've been letting this run for a while now, and we'll see that the failure rate has dropped significantly. Our success ratio has increased quite a bit, and we now have quite a number of success outputs from our executions. And if we actually go to our executions list, we can start to see that this is running sequentially, and we have a whole bunch of these success states for our execution. And as we can see here, if we were to go to the outputs, we can see that this is creating all of the data for our stock portfolio and also the output files here. So this is the JSON, which we get here, and the current market JSON here. So this is continuing to run, and this is running because we have this scheduled execution flow, which is a cron job. So every 5 minutes, this is going to be executing, and we see that here. So this means that our flows are set up to work correctly, and we have these two flows that are ready, but only this one is operating on a schedule. This Y-Finance flow was one that we just ran as a one-off, but this is the one that will be running regularly. So that's why we see all these executions happening in our Kestra dashboard right here. Now, we touched on this a little bit earlier, but one of the superpowers of Kestra also is the ability to provision and declare infrastructure as code through YAML. So what does that mean? So what we can do is that when we go to blueprints, we can actually configure YAML files that will provision cloud architecture patterns that can help us build systems to support this automated workflow orchestration. So one of the things that we can do when we go to blueprints is we can, for example, create an S3 bucket. So right now, when we have our dashboard, and I'll open up the other window over here. So when we have these executions and we get all of this data, what we're doing is that we're logging this information as outputs. We do get JSON files here. This is JSON, and we also get the actual values here. But something that we could do is that if we wanted to build a data lake, if we wanted to be able to query across all of this data, create dashboards, create web applications, we're going to need to pipe this data into the cloud somewhere. So one of the things that we can do is that we can take this type of blueprint that we just got from the Kestra list of blueprints, and we can click use. And now we can start to create our own execution workflow to enable us to, for example, create an S3 bucket. So to do this, what we'll do is that we are going to start building out some of this code. So we're going to call this create S3 bucket for data lake. We'll then change the namespace to tech stack playbook. And then in the inputs, what we're going to do is that right before this, we're going to create a list of variables. And these are going to be several values. So we have our AWS access key that we're going to need. We need our secret access key. We'll also need a region. And we're going to declare those like this. So we'll say AWS access key ID. And that'll be equal to a string. We'll copy this. We'll say secret access key ID and AWS region to be set to empty strings for now. We'll basically create these values in a moment. And then in the inputs, what we're going to do is that we're going to have this bucket is going to be a string, and we're going to create our own custom name for this bucket. So we're going to call it TSP stock market data lake. Actually, we'll just say TSP stock market data lake. Now we'll say that this is required as true. Now in the task, this is going to be create bucket. And we can actually call this create S3 bucket just to be super specific. This is going to be the type Kestra plugin AWS S3 create bucket. And then we're going to basically have this access key, the secret access key, this region, and then the bucket input, which is going to come from here. So this is an input that we'll create. Otherwise, it'll have this default that we'll put in. So this is going to be great. But now we need to go into AWS and create these elements. So before we go further, just want to review this again. So for the variables, we're going to be passing these in. If you have an enterprise license with Kestra, you'd be able to define secrets. But because we don't have that feature, we are just going to use the free services that are available. So we can define these variables as inline text. Obviously, these are going to be secure credentials. So I'm going to blur these out in this video when I'm going through this. But if you're working in your own environment, you might want to use something like Secrets Manager or any sort of like vault to keep those credentials secure so that you're not hard coding them. Obviously, this is a tutorial, so I'm just showing you how I would go about this in a quick manner. But if you want to provision in a really secure way, you would want to have a way to fetch these values as opposed to hard coding them, which I'm going to do. And again, if you had an enterprise plan, then you'd be able to do this. Also, some of these managed services for managing secrets may have a cost, so just be aware of that and make sure that you know exactly what you're using. But since we're going to be defining these as variables, this is something that we can do for free. So what we're going to do is that we're going to log in to AWS, and we're going to go to IAM, which is Identity and Access Management, and we're going to do create user. We're going to then call this Kestra permissions. We'll say next. And what we're going to do is that we're going to attach policies directly, and we're going to create a policy. Now, there's going to be a bunch of permissions that we are going to want to create for our bucket to actually work. So I'm going to define JSON, and I'm going to copy this in, and then we'll walk through all these parts of it. Okay, so this is just the policy editor for writing an IAM policy. So we define the version, there's a statement, and then we're going to have two statement IDs. One that's the Kestra S3 bucket creation, and that's going to allow us to create a bucket, put a bucket policy, and put bucket tagging. And that's going to be creating a bucket called TSP stock market data lake. And that's going to be corresponding to our flow that we are defining here. So that's here, right? This is going to be our S3 bucket name right there. Now, this S3 operations, so the Kestra S3 operations statement ID, is going to allow us to put an object, get an object, list a bucket, and delete object. So this is going to also give permission to this same S3 bucket, but enabling us to then upload. And we're going to do this process in a bit, but this specifically allows us to create that bucket, and then this is going to allow us to upload files or remove files to that bucket. We actually won't be deleting any objects, so we can just delete that. And one of the really secure tenets of building in the cloud, especially on AWS, is least privileged access. So because we don't want to be able to delete items, we will then remove that permission from this statement ID. So we could only put, get, or list bucket. So that sounds great. And then this, just note that this is for putting items inside of this bucket. If you have like subfolders or subdirectories underneath this. Otherwise, we want to be able to create this bucket and also get information about the policy. So this all looks good. We will close this out, and then we'll click next. And this policy name, we'll say this is Kestra permissions policy. We'll be sure to copy this to our clipboard. We'll say create policy. This is going to create that policy, and we see that it was created, which is great. Now what we'll do is that we'll go back to create user, and we're going to attach policies directly. So we're going to refresh this, and now we're going to search, and we see that Kestra permissions policy is there. We'll give that a click. We'll click next. And now we'll click create user. Perfect. So now we will go back to Kestra permissions. This was what we just created. We're going to create an access key. We're going to click CLI. We will say, I understand. We don't need to create a description. And then we're going to create an access key. So these are very sensitive credentials. If anybody was to get access to this access key, they would be able to use any of those actions that we defined in our policy. So you want to be really careful about not sharing these with anybody that doesn't need them. Obviously for this tutorial, I'm going to be hard coding these into my scripts. You should not necessarily do that. You should definitely use a security or a environment variables or some sort of like secrets manager for managing this. But since we're on the free plan, this is a way to basically store these values in the script. Just I'm going to be blurring these out because these are sensitive credentials. So just be aware that these, if someone was able to get access to these keys, they would be able to then do those permissions or those actions that's defined by the IAM that's behind that IAM user. And these are also long-lived credentials, so there's no key rotation. So you would either need to create a new key and rotate the permissions or have a service that does that for you. So AWS has Secrets Manager. You might want to use this, but again, like you might want to think about costs as well. So we're going to put these keys into our script. So we'll go back to our flow. We're going to put this access key ID here, and then we're going to go back to this. We're going to take the secret access key. We're going to put this in here. And then the AWS region is AWS, and then it's US East 1. So AWS region, US East 1, and then we have access key and secret access key. Perfect. So now we're going to give this a save. And now we'll replace these values with what was in here. So we're going to do vars dot AWS access key. We're going to do the same thing except secret. That's the same value there. And then for region, we'll do vars dot AWS underscore region. So we have each of these values going into our task for Kestra. We'll give this a save. We will then execute this. We will execute it. And we'll wait for this to run. We see that this was successful. So now if we go back to our AWS account, we go to S3, we should see that there is our bucket, which is TSP Stock Market Data Lake, which is great. So that meant that we're able to provision infrastructure as code YAML file in Kestra that was able to deploy and create this S3 bucket without us needing to go into the console or write some code. We were able to just provision this infrastructure as code in Kestra, which is pretty great. So now what we're going to do is that we're going to now automate this process to take our script that is getting the data from Yahoo Finance, and then we'll upload that every 5 minutes to this S3 bucket and build out our data lake. Now to give some context to building out this data lake and what that really means, let us diagram this out a little bit. So right now, and let's do some diagrams here. So right now we have Kestra, and Kestra is able to ping Yahoo Finance PI, and that's set on a cron job. So this is going to be my little clock. So that'll work for now. So it's basically pinging this on a schedule, and then it's going to take this data and then save it back as JSON. So that's all happening within this Docker container. And remember, this is all happening in Docker. But right now, this all just sort of lives within this system. Now, if we want to integrate this into the cloud, what we really want is that after this happens, we want to then send this data back into the cloud. So we're going to put this into AWS. Now, what's going to be happening here is that, and we're going to break this down a bit. So if you want to do any sort of querying or monitoring or building out dashboards across all of this data, right? Like you might want to make a chart and sort of see like it went up, down, 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 up, 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 something like that. If you wanted to see, you know, this data and what it's doing, you're going to need to build out a data lake so that you can then visualize this information. So what we're going to do is that we are going to sort of explain a little bit of how this data lake is going to work. So we are going to have a bucket. So this is S3. So this is going to be our stock market data lake, right? So then underneath this, there's going to be the different types of JSON. So there's going to be market data, and then there's going to be alerts. So under market data, that's going to have two different types of data. There's going to be current, and then there's going to be historical. All right. Let's see if I can move it. Yes, move it up a bit. Okay, cool. Because I just want to move this part. There we go. Okay, cool. So the alerts and the historical data, this is how we're going to be provisioning this S3 data lake. Now under current, we're going to do something where we're going to take, I'll draw this out. So it's going to be the year, and then it's going to be the month, and then it's going to be the day. It's then going to be the hour, and then it's going to be the minute. And then that's where you're going to put the JSON right here. So everything's going to follow this year, month, day, hour, minute, because everything's happening on this 5-minute span. So that's where we're going to then have in market and in alerts this year, month, day, hour, minute, and then we're going to put the file. So every time there's something that's in within the given hour, it'll go in here. And then once the hour increments up, then the files will start incrementing in minutes in this new hour. Once the day is there, then the same process replicates. But we're going to be structuring all of this data within this type of workflow. So you'll see that for the market data and then for alerts. So to accomplish this, we are going to go back to our flows. We're then going to find where our simple market monitor is. We're going to go to edit flow. And now we're going to basically add in those AWS components into our variables, and then we're going to reference those as separate tasks to upload that data to S3 every time that this runs. So what we're going to do is that we are going to copy our information that we had in the previous step. So if you remember from before, we've got our AWS access key ID. We have our secret access key ID. We have our AWS region, set to empty string, and we're going to have our S3 bucket. Cool. So our S3 bucket is going to be this, and then we have US East 1 for the region, and then our access key and secret access key, we will pull those from our previous flow. So we'll copy our secret access key that we had from the last step, and then we will copy also that secret access key from before. And we'll add that underscore there. Okay, great. So now what we'll do is that we will bring this down and we'll start continuing along to the rest of the components of our build. So now that we have our variables in place, now what we're going to do is we are going to now add some new tasks. So we're going to scroll down all the way down past generate events, but we want to find out where this line item is, because this is going to be where we create our next tasks. So what we're going to do is that we are going to create a few different tasks. So this first one is going to be current market. We're going to have another one, and that's going to be upload market data. And then we're going to have a third additional one. It's going to be upload alerts. So now what we're going to do is that we are going to define type. We're going to say IO, Kestra, plugin, AWS, S3, upload. We're going to add this same type to all of the tasks. And then we're going to create a run if statement. So what we're going to do is that we're going to pass this in and we're going to say run if, and I will make this text a little bit bigger so it's easier to see. So what we're going to do is that we're going to say basically execute this task when market monitor is having a status of success. So we need market monitor to run before we're able to get this because we need the JSON file. So this is going to be also for upload market history, but we're going to switch this up for this last one for upload alerts because we need to make sure that this is generate alerts. So this needs to run because we need to make sure that the alerts are there so that we can upload them. So this one is separate from these two, but they all have a run if statement. Okay. Now what we're going to do is that we are going to then get that data. So we're going to say from, we're going to take the outputs of market monitor, output files from Kestra, which is the Kestra API, and then we're going to get the current market.json file. We're going to do basically a very similar thing for this one, except here, this is going to be outputs market monitor output files market history.json. So completely different file, and then very similar with upload alerts. We're going to say from outputs generate alerts, output files, and then alerts. So that's the third type of JSON file that we are going to work with. And for the bucket that we're going to be working with here, this is going to be the same. It's going to be the variable that we put in for that S3 bucket. We're going to copy this, and we're going to also put this into this task and this task. Also, something that we're going to do is that we're going to add a key, and this is going to define where the files get put. So we're going to create a statement here that's going to be a little bit long, but we're going to say market data, and this is where inside of this S3 bucket name, we're going to have a subdirectory called market data. This is going to be current, and then because we're defining current market, and then we're going to have the date. So we're going to be putting the year, the month, the day, the hour, and then the minute, and then / current market JSON. So this is going to basically tokenize these elements into subdirectories where it'll be filtering down by the year, the month, the day, the hour, and then the minute. And then the JSON file will be put there. Now we're going to be doing a very similar process for upload market history. So Again, we're going to use this same type of structure, except market history.json is going to be what the key ends with. And then very similarly with alerts, it's going to be literally the same thing, except, alerts here, date is the same, and then it's going to be /alerts.json. Now we're going to take our access key, our secret key ID, and our region, and we're going to append these three values to this task. So that'll be able to pull out the access key ID, the secret key ID, and the region. And we're going to put that in to this task as well, and also to this one. So that pretty much rounds out this. We'll give this a save, and now we will execute this. And let's see if this works. So we'll give this an execution. It's going to run, and we're going to see a lot more outputs now because we have more tasks. So great. So it looks like everything passed, which is great. We have success messages across the board, which is perfect. So now in our flows, we're going to be having this updated simple market monitor. So we just updated this one. So now when we upload this, or basically when we run this file, because we uploaded this S3 bucket and created it, now when we run this execution automatically, it should start pre-populating our folder with data. So let's see if it did that. So if we refresh in S3, okay, so it looks like we have market data. So now this is creating our data lake. So we can actually see how this is being created. So we have current, now we have 2025, we have 01 for January, we have 31, and we have 08. So that's the 8th hour, and then 47th minute, and then now we have our JSON right here. So this is how we're able to start creating this type of structure where we have our data lake of data here, and then we can basically tokenize or extract by the year, the month, the day, the hour, or the minute, and then we can get all of our files. So this is going to be really helpful if we wanted to query across, all of the days in a month, or the months in a year, or all of the years. We'd be able to do that. Same thing here. So if we go back to market data, we can also go to historical, and then we are getting all this data. This is what was generated from today, and we're able to see the market history file that we created, and that Kestra really is creating for us, which is great. And then also if we go back here, we have alerts, and then this is where we're able to start porting out the results. So this is where we're going to, again, be building out our data lakes across this different type of implementation. And we can start to then see how we can query across all of these different data, date, and time points, which is awesome. So now we're going to go back to our dashboard, go to zoom out. And now we're going to wait a little bit, and we're going to see how these data points get put in. So we're going to go back to our executions, and we're going to wait for more of these events to run. And then we'll start to see that our data lake is going to populate with more information. So we'll wait for these files to be there. So for example, this just ran. So we had something at 47, which was the instance, and then we're running it, every few minutes. So now this is at 50, and we also get this data. So now you're going to start to see that as you let this run, Kestra is going to be piping data now from this instance in Docker now into the cloud, and now we're going to have full portability. We could download the JSON files to our laptop. We can also get this data in the cloud, and once you start putting data in the cloud, you're able to then do so many advanced data science and data analysis and analytics around all of this information that we're tracking. So this is where you're going to really be able to start building out your portfolio dashboard, because now you're going to be able to take all this data, it's all running in an automated way, and now you're able to then start building out your data lake to analyze how your portfolio is doing over a period of time. So now you're not just reliant on the data that's on a website at a given time. You can start to build out this historical record of information related to these stock prices, which is pretty cool. And of course, we're able to still monitor the success ratio, so we can see that our success ratio continues to increase, the failure ratio continues to decrease, and we're able to then start making sure that we are having all of these success ones. So example, we were able to debug this, we were able to fix it, and then now we're able to ensure that our builds are getting the data that they need and that our workflows are running optimally, which is great. So where do we go from here? Well, if we want to take this and productionize our workload, Kestra gives us a number of different options, and they have a great installation guide in their docs about how to take Kestra and deploy it. Now, obviously, the easiest way is with Docker, and we were doing that locally within Code Sandbox, which is a virtual machine or a dev box. But if we wanted to productionize this, we can, of course, use Kubernetes and install Kestra in a Kubernetes cluster with a Helm chart. We can also leverage AWS EKS with Amazon RDS and S3 for our Kubernetes deployment and leverage Postgres database and object storage. You also do have the option of Google Cloud Platform with GKE and Cloud SQL as a database. You also have the option to deploy Kubernetes on Azure AKS with Azure Database and Blob Storage. You can also deploy this with an EC2 instance on AWS and also leverage RDS and S3 and DigitalOcean, Azure. You could run it as a standalone server, Podman, and then also Kestra Cloud is currently in alpha, but by the time that you watch this video, this might be live. And Kestra is also working on a way to host and deploy their own infrastructure with their own systems. So you have a number of these different options to go with, and I believe a lot of it will just be a familiarity. So for example, like if you're familiar with Amazon EKS, which is the Elastic Kubernetes service, and RDS and S3, you might want to leverage your AWS account to then go and deploy. So for example, you could launch your EKS cluster, you can install kubectl and EKSCTL, and then you'd be able to then start running your Kestra cluster within Kubernetes, and then launch RDS, prepare your S3 bucket, install Kestra within the AWS EKS cluster using a Helm chart. You define your YAML and all this stuff. And then if you want to deploy the UI, for example, which we saw in the preview with the port, you could then use something called an application load balancer, an ALB controller with Helm chart to be able to then render the UI that Kestra creates. So you have a number of different options to deploy. The main thing though is just as you think about hosting this, of course, when we were running this in Code Sandbox, for example, this is running on dev credits. So you will need to think about this of what are the costs and the requirements that are needed. So always make sure to check pricing calculators and see basically, sunken costs of deploying your infrastructure. So if you're choosing, any one of these different types of systems, are you, keeping the budget, optimized for your spend and what you're expecting to run? Otherwise, you can definitely run this locally and run this on your computer, and then you also would be, saving money. The other thing also to think about is in terms of enterprise. There are a lot of different options when you have an enterprise plan. So of course, for this guide, we were just talking about the open source plan for Kestra, which gives you so much value. But if you do want to get more out of your instance. For example, if you did want to use secrets as opposed to needing to hard code all those values, then you could leverage their secrets manager. You also could leverage authentication and use a lot of the single sign-on, auditing, centralized task config, allowed namespaces, API tokens, building applications. So this would build a custom UI for what Kestra creates, as opposed to needing to pipe that data into something else and then build your own UI. Kestra has their own implementations for that. You could also build your own custom blueprints. There's a whole bunch of like RBAC, role-based access controls, invitations, secrets, which we mentioned, and secrets manager, task runners. There's a whole lot of these different features. So it kind of all basically stems down to what do you need to spend, what do you need to pay for, what can you use for free, and you sort of leverage all of these different considerations, and that's how we end up building technology like this. All right, so we just went through so many topics, and we got to really dive into how we can build our own data orchestration pipeline to be able to take very relevant, very real-time data from the stock market and then pipe that into our own data-driven workload to be able to analyze our portfolio. And what's really interesting is that when you use Kestra, for example, a lot of the orchestration patterns that would be very complicated to be managing these in separate scripts that might not be all organized together, you can aggregate a lot of these elements together and create very complicated workloads very easily, or at least not as complicated as they might need to be. So let's review a little bit about what we did today. So first of all, we learned how to leverage Docker to run Kestra in our own Docker container, and we were able to learn how to run Kestra locally with their free open source plan. We then learned how to write our first series of YAML scripts to automate a workload, and we learned how to build a container with Kestra that could pull data from Yahoo Finance API with YFinance. So that was the first script that we were able to do. We were able to get data from Apple. Then we were able to automate the ability to check multiple stocks. So that's where we're able to get, Amazon, Nvidia, Microsoft, Apple, Google, and then be able to basically iterate over all of those different stocks and then create a data object and then create JSON files of that data historically every 5 minutes throughout the day. We then got to take that script and iterate over several times to see how we could improve and how Kestra helps us with organizing and optimizing our containers so that we're able to write better, more complete, more concise code and learn how we can leverage logging and auditing and monitoring of the executions of those iterations and executions so that we're able to see what succeeded and what failed and help us optimize our code moving forward. Also, something that we were able to do was learn how to take our files and then port those into the cloud. And of course, we were using Amazon Web Services, AWS, and we got to learn how we could use Kestra not just as an orchestration pipeline, but also as an infrastructure as code tool to be able to provision cloud resources for us. So we built an S3 bucket, and then we were able to build an event-driven workflow to take as tasks those JSON files that are created in our Kestra execution to then port those into Amazon S3, which is object storage, and create our own data lake so we can then historically track the prices of our portfolio over a series of time, which again, like learning how to build a data lake is really important because if you work with big data, you can then query, you can analyze, you can do a lot of monitoring and observability over a whole series of time sequences, as opposed to, again, just checking the price of a stock at a given time. You'd be able to historically analyze this over weeks, months, even minutes or hours. So we learned so many really exciting topics. And then, of course, we're going to leave it with how you could then host and deploy this on your own infrastructure, or, of course, run it locally. So with that, I hope that this video was really helpful and eye-opening for you to see how you can build really complicated workloads very easily with a tool like Kestra and some Python to be able to then track real-time stock market performance. So this is something that would cost tens or hundreds or even thousands of dollars to get access to this type of data, but we just built an event-driven workload for free to be able to do that with Kestra's open source plan. But of course, if you want to level this up, productionize this, there definitely are cost considerations for you to pursue, whether that's taking on the enterprise plan or if that is looking at a cloud provider to host your infrastructure with their managed services. But of course, definitely be sure to check out Kestra's GitHub. I'm going to include a link to that in the description below. Also, I'm going to include links to all the code that you saw in this tutorial so that you'll be able to check this out. And with that, I hope that this video, again, was really helpful for you and eye-opening for you about the power of automation and orchestration. So with that, hope you have a great rest of your day, afternoon, or evening, wherever you are tuning in from in the world. And I'll see you next time. Thanks, everybody. Bye.